Evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to my latest video. This video I found really interesting. I wanted to make it, and this is really all about forecasting the weather using wind direction here in the Hampton Roads, Virginia cities. This I think you will find very interesting. I'm going to go ahead and kick it off right now. Let's do it. All right, so starting off with the overview of tonight's video. Over the course of many years, I have meticulously observed the relationship between wind direction and the weather to include the state of the sky. One thing I want to really emphasize is wind direction plays a significant role for the weather across Hampton Roads, Virginia, as air masses are blown into and out of the area. In addition to air masses, the weather is highly dependent on the season. Prevailing wind direction does change from one season to the next, and you'll see that here as I go through the slides in this presentation. Specific cloud types are visible clues of the future weather. I mean, if you really want to forecast the weather accurately, you need to be a master weather observer. You need to really pay attention to not only the wind direction, but what does the sky look like? What kind of clouds do I have on a particular day? So in this guide, I decided to focus on the prevailing wind directions and the typical weather that you would see across Hampton Roads, Virginia cities in the summer as well as the winter seasons. Okay, so before I really get into the different types of wind directions and the associated weather, I think it's important to look at our air masses. Air mass is simply a uniform body of air with similar characteristics in temperature and humidity. In Hampton Roads, Virginia, we are generally influenced by the following air masses, and I'll break it down winter versus summer here. Now, when I say winter in this video, I'm talking about meteorological winter from 1 December right through the end of February. When I say summer in this video, I'm referring to 1 June to the 31 August time period, the meteorological summer months. All right, so for winter time, the meteorological winter time in December, January, and February, we typically see a continental Arctic air mass. Now, one thing about continental Arctic air mass in general, the continental Arctic, it's very cold, it's very dry. It's where you're starting to like touch things and you get that shock, right? The static builds up and you kind of shock somebody when you touch them. That's how dry the air is. Now, continental Arctic air does occasionally visit Hampton Roads cities in the winter, but it's not as common as this continental polar air mass. Now, with continental polar, you notice it's just cold and dry. Continental Arctic is very cold and dry. So there's a difference there in the description, right? Continental polar air masses are very common in the wintertime. They typically move into our area, Hampton Roads cities, from the northwest. Maritime polar air, on the other hand, this is a cold and moist air mass that we will see also during the winter season. This is also very common. So, as we'd expect in the wintertime, we get more of a prevailing northerly wind direction, whether that's northeast off the Atlantic Ocean waters, and we have a maritime polar air mass in place, or whether it's coming from the northwest from Canada, right on down in through Hampton Roads cities where it's cold and dry. Additionally, we occasionally are visited by what's known as a maritime tropical air mass. And for maritime tropical air mass, that's simply an air mass that is warm and moist. This is not as frequent in the wintertime, the maritime tropical air mass. But it does vary depending on atmospheric circulation during the winter seasons. And this varies from each winter, from winter to winter. There's some winters where it's extremely mild and above normal, and we have maritime tropical air masses visiting us more often. And other winters, it's less frequent, and we have more of these continental polar and maritime polar air masses visiting us. Now, during the summertime, June to August, meteorological summer, we see really three type of air masses I'll discuss. Maritime tropical air masses are warm and moist. These create that very warm and muggy, sometimes hot and muggy conditions, maritime tropical air masses. This is very common in the months of, late June specifically, late June, July, and August. This is quite the common air mass, maritime tropical. You'll walk outside and you're immediately sweating because it's so humid and muggy. Maritime polar air masses occasionally come down through the area in the summer months. Really, that focus is on in early to middle June. We occasionally see these maritime polar air masses and the wind shifting to bring these air masses in. But it's very rare to get maritime polar air into Hampton Road cities in July and August. We're just happening right now here to begin August. We had some very pleasant weather for early August standards recently, where we actually did have some pretty strong onshore northeasterly winds in association with maritime polar air mass. But again, it's very rare in most Julys and Augusts. Continental polar air, this is a very rare case in the summer months. This is where you get that cool Canadian air coming in from the Midwest and Ohio Valley to come down through Hampton Roads. But a lot of cases, it just can't make it into here. Here's the overall breakdown of all the air masses depicted for you. You can kind of see where they develop, where they form. So you'll notice generally what we have here, we have MP, which is a maritime polar air mass, forms over the unfrozen North Pacific and North Atlantic waters. We have the continental polar air mass, the cold and dry air mass, which forms over Canada. We have maritime tropical air masses, generally over the Caribbean, as well as the tropical areas of the Atlantic Ocean, as well as the Gulf of America as well, maritime tropical air. You see this arrow here. And then we have maritime tropical air also off the west coast of the U.S. there towards Southern California. But in general, for Hampton Road cities, continental Arctic air masses in purple here, they can CA. That can occasionally get us in the wintertime, but it's not very often as frequent as the continental polar air masses, which are way more frequent visitors to our area in the wintertime. And then maritime polar air masses also here off the North Atlantic. All right, just realize one thing when we look at these air masses, and I'm going to move on. The wind is going to blow these air masses into and out of the area. Okay, so the wind direction is critically important as to what air mass is coming into your area, as well as what is your predominant weather going to be like. So let's start off in the summer season, and let's look at the months of June, July, and August. And I like to call this summer season the cumulus season because predominantly we have cumulus clouds that are seen across the sky in the summer months. Let's first examine what southwest winds do. Now, when I examine the summer and the winter seasons and the prevailing wind directions, I'm using the most predominant winds here, okay? So in the summer season, we have southwest winds, southerly winds as well, quite a bit. That's the predominant prevailing wind. So southwest winds in the summer season for Hampton Road cities result in hot, muggy weather. We have maritime tropical air mass coming into our area. We typically see these dew points, which are a measure of the amount of low-level moisture you have in the atmosphere. These dew points exceed 70 degrees Fahrenheit when you get these southwest winds and the hot, muggy weather and this maritime tropical air mass in place. Scattered thunderstorms occur during the maximum heating of the day. So we're talking afternoon into the evening hours across Hampton Roads. The hottest temperatures, by the way, when you have southwest winds, the hottest temps generally are into the 90s. And they typically occur in July. For Hampton Roads, the hottest time of the year is generally that second to the beginning of the third week of July. And also, one other thing I want to mention, the stronger these southwest winds, the hotter the potential temperatures will be. Now, southwest winds are the prevailing winds during the summer months across Hampton Roads. They generally occur on the backside of a strengthened Bermuda high pressure, and I'll show you a graphic here in a moment. Now, in the absence of a synoptic scale pressure gradient, so let's say, our transiting highs and low pressure systems, let's say, they're not very strong, that's going to result in a weaker synoptic scale pressure gradient. And when you have a weaker synoptic scale pressure gradient, you get this land sea breeze mesoscale, or a smaller scale circulation, which sets up with air rising over the heated land during the daytime. The wind blows in from the water toward the land. The air rises over the land, and that results in potential isolated scattered thunderstorms when you get this sea breeze to kick in the absence of a strong synoptic scale pressure gradient. You generally get light east to southeast onshore winds at 5 to 10 miles per hour during the daytime. And again, that wind is directed from water because the water is relatively cooler as compared to the air over the heated land. Now, through middle June, you can get what's known as backdoor cold fronts, which occasionally drop into the area from the northeast. And we'll get a temporary wind shift to the northeast behind these backdoor cold frontal passages. And I'll show you an example of what a backdoor cold front looks like here in a moment as well. Now, outside of tropical disturbances like right offshore, northeast winds generally going to bring low stratocumulus clouds, flattened cumulus clouds, into the area as a maritime polar air mass influences the weather. So we get these cooler, but it's still fairly moist air mass when you get northeast winds, get this lower stratocumulus or flattened cumulus clouds to move in off the Atlantic waters. If a tropical cyclone is close enough to our coast, you will see with northeast winds, you can still get bands of showers, could be heavy at times with these northeast winds with the tropical cyclone influence. So generally, you have to look at things more specifically with tropical disturbances. If a tropical disturbance is off the coast and we have northeast winds, it could bring heavier bouts and periods of rain showers. But outside of tropical influences, generally a northeast wind is going to result in these low stratocumulus clouds. Here is what is the predominant pressure system that really affects our areas here on the East Coast in Hampton Roads, Virginia. You get this strong Bermuda high pressure system is very dominant. It expands to the north it moves northward and expands. It gets bigger. You see these red arrows on the back side. You see these white arrows represent the circulation around high pressure in the northern hemisphere. So generally you're getting northerly winds on the east side of the high pressure, and then you get more of a easterly wind south of this Bermuda high. But look at the red arrows here towards the East Coast. You're getting more of the southwesterly winds on the backside of this Bermuda high pressure system. Additionally, this Bermuda high is very important as far as steering tropical cyclones. Where do these cyclones typically go? Do they impact the United States, these tropical cyclones, or do they just go and curve back out over the open waters of the North Atlantic? So the Bermuda high plays a huge role in our weather with these southwesterly winds on its backside. Generally, what we're looking at is hot and humid weather most days in the summer months. This is our one potential source of relief in Hampton Roads in the summer season. This is called a backdoor cold front. So again, you notice this white H represents high pressure over New England, and then you get these white arrows represent the clockwise circulation around high pressure in the northern hemisphere. So what it does is these northeast winds kind of push this front from northeast towards the southwest. And so it's coming from the opposite way it normally would. Normally, the cold fronts are going to come from the Midwest and the Ohio Valley towards Hampton Roads. But in this case, it's called a backdoor cold front because it moves from northeast to southwest. And sometimes these get all the way down into North Carolina, specifically in the month of June. I've seen this quite a bit happen in June. Will allow for a temporary relief from any heat and more of a cool, moist air mass, that maritime polar air mass right behind this frontal passage. Now, in the summer season, we really have to understand, in June, July, and August, we have vertical air motion that occurs primarily via what's known as convection. So you get the hot sun over here in this graphic on the left, get this shortwave radiation, these yellow arrows hitting the ground, and then you get this rising air motion over the heated land. The sun is very intense in the summer months, very high in the sky, very strong solar radiation inbound, and hits the Earth's surface. And then the air gets heated near the Earth's surface and it's less dense, so it wants to rise. And it forms these puffy cumulus clouds, and we call that process convection. If we were to look at you can look at this example in your home by basically just taking a pot of water, boiling it, Now you'll notice when the water is boiling, you'll see these little bubbles kind of break free of the water surface. And this is basically what's happening within the water as it's heated up and starts boiling as we get these convective currents, these red arrows, rising air motion, these little convective cells or currents. So the red arrows indicate upward vertical motion. We'd have the atmosphere with convection. The blue arrows represent compensating sinking air motion in association with these convective cells. So again, the big deal here is in the summer months, the sun is very high in the sky. It's very intense with this solar radiation coming in and hitting the Earth's surface. The land heats rather efficiently, and it results in less dense air over the heated land rising upward in the atmosphere and results in convection. All right, now, one other thing to say about summer season, it's extremely rare for a cool front. I'll say cool front. It's not even a cold front because it's summer. So there's not much temperature difference ahead and behind these fronts. So I'll call it a cool front because that's exactly what it does. It just temporarily cools the temperatures down for us. It's very rare to get a cool front, though, to pass through Hampton Roads from the northwest during the summer season. So, you think about fronts that occasionally pass through cities like Chicago, the Midwest, Milwaukee, up in the upper Midwest areas, Michigan, the upper Great Lakes. They usually don't make it all the way down through Hampton Roads from the Midwest and Ohio Valley in the summer. And it has to do with the strength and the resistance provided by this very strong Bermuda high pressure system. As the front's trying to come in from the northwest towards Hampton Roads, this high pressure is so strong that the front will generally stall out. And I'm going to talk about that here. Most of the cool fronts are going to stall out across central Virginia or generally along the Virginia-North Carolina border, with Hampton Roads remaining generally on the very warm, muggy side most of the time, south of these stalled frontal boundaries within this unstable maritime tropical air mass. So we just really don't get much relief with cool fronts coming in from the Ohio Valley and the Midwest in the summertime. And again, it's due to this very strong Bermuda high pressure system. It provides strong resistance. Fronts just can't get through that strong ridging associated with that Bermuda high. We do see scattered thunderstorms a lot of times, generally south of these stalled fronts, with heavy rain showers and gusty winds across Hampton Roads. You get diurnally driven heating of the air mass as well. And along sea breeze, thunderstorm outflow boundaries, you can also get scattered thunderstorms to fire up. So these are generally the methods in which you get the air to rise vertically, the convection I talked about, get the scattered thunderstorms to develop, get heavy rain showers, get those gusty winds with the downdraft cooler air coming down from the top of the cloud. And generally you get this type of pattern with southwest winds, south winds as well as southeasterly winds in the summertime. Now, I wanted to show you from my own data here how the southwest winds dominate the summer. Over on the upper left, I've got the month of June. Over here in the upper right, I've got the month of July. And in the bottom here, bottom center, I've got the month of August. And this is for Virginia Beach. And you see that we have wind directions here on this vertical axis here, and then we have the dates on the x-axis, this horizontal axis, okay? So you'll notice these blue dots represent the frequency of wind directions, and generally what we're looking at here, early June, southwesterlies, southeasterlies, southeasterlies, occasional, very rare north and northeasterlies in the summertime in June. And then it goes back to predominantly more of a south-southwest prevailing wind direction in late June. Now over here on the right, we're showing wind directions represented by these blue dots. When they're clustered really close together, that indicates a higher or greatest frequencies of that wind direction. So in July, we see nothing but solid blue clusters of dots here, right? All the way through the month, pretty much indicative of a south to southwest prevailing wind direction. Here at the end of July in 2024, we actually had a brief switch over to east to northeast winds. But again, it's not very common. Look at this, just follow this, just draw a line straight across this cluster of blue dots, indicating a very strong increased frequency of south to southwest winds across Virginia Beach in July. Now, August is here on the bottom center. Last August was kind of a strange one because we actually had more frequent northeast winds towards the end of August last year, which was very rare. It brought the humidity values down quite a bit, the dew points. Initially, though, at the beginning of August last year, we had a major cluster of blue dots here in the southwest wind direction prevailing right on through about mid-month or so. Then we had a little bout of cooler, maybe northeasterly winds from around mid-August last year, and then back to southwesterlies again, and then a little bit of a strange cool down there at the end of the month. But in general, southwest winds dominate the summer season. This is I'm showing you the same order here. This is going to be June in the upper left, July's upper right, and then August is the bottom center here. The blue line here represents your dew point, which is a measure of how moist the air is or how muggy it is. And so you'll notice this blue line in June, it does have some dips here. We're still getting those backdoor cold frontal passages in early June. You see this blue dew point line, how it drops off? That means we're getting drier air to kind of blow in here on those northeast winds, onshore winds. But then you notice the blue line kind of just steadily increases as we get into late June. And then over here on the upper right, look at the blue line, the dew point line, getting really muggy as it basically increases into early July, and it kind of just remains up at those higher levels, the 70s, upper 70 dew points, and then it dropped off last summer anyway in July towards the end of the month. And the bottom here, we're showing mainly, this is what the norm is here. Maritime tropical air is brought in by these southwesterly winds, the predominant southwesterly winds. The dew points range between 75 and 80. Last year, again, it was very odd because we had this drop off last year. It was really odd, where the dew points got down to around 55 degrees around the 22nd of August. But in general, that's not the norm for Hampton Roads. Now, let's correlate the wind direction also in the months of June, July, and August. Let's correlate the southwest winds and what the sky looks like across Hampton Roads cities. Now, all these cloud photos you see, I personally took these. So generally what you have with southwest winds, or maybe you have like a light east to southeast wind onshore during the day due to a sea breeze effect, you're going to get these billowing, puffy cumulus clouds. See this in all three pictures. This indicates an unstable atmosphere, and these type of clouds here are generally going to precede scattered thunderstorms in the afternoon hours into the evening hours for some location within Hampton Roads. Additionally, with southwest winds or these very light sea breeze winds, you're going to have high temperatures generally around 90 degrees in the months of June, July, and August, with dew points into the 70s, making it very muggy. Any dew point excess of 70 degrees Fahrenheit makes it feel very muggy outside. Now, what happens if we flip the winds around in the summer season at Hampton Roads for June, July, and August northeast winds? Now we got an onshore wind. Southwest winds are offshore winds. They blow from land toward the water. Northeast winds blow from water toward the land. And you got to kind of think of things relatively here. When I have winds blowing in from the North Atlantic in the summer season, those water temperatures are going to be relatively cooler. And so it's going to blow in slightly cooler air from the Northeast into Hampton Roads cities. Now, I just took this picture last week. Actually, it might have been over the weekend. Yeah, it was over this past weekend where we have northeast winds blowing into Hampton Roads. Now, notice the flattened shape of these cumulus clouds that I took, this picture. There are some higher layers, some cirrus, you see a little bit of wispy cirrus above these flattened stratocumulus, these flattened cumulus clouds. Also, looks like some cirrocumulus type clouds as well, some higher clouds. More examples here in the middle and on the right. See the flattened shape or appearance of these cumulus clouds? This indicates generally fair weather when you see these type of flattened cumulus. The atmosphere is very stable on these days. In many cases, what you get with northeast winds in the summer is a partly to mostly cloudy sky. Really, that's the main weather you'd expect with them. Unless, of course, you have a tropical influence right offshore. And that's going to be a whole different entire thing where you're going to have an overcast with the tropical system if it's right offshore. You're going to get periods of heavy rain showers with northeast winds, perhaps on the backside of that tropical system. But outside the tropical disturbance influence, this is what you get for northeast winds during the summer season at Hampton Roads. Now let's flip gears to the winter season. I'm going to use the meteorological winter months, December, January, and February. I like to refer to this as strata season because the clouds are always very layered in the cold time of year. Okay, I'll show you why here in a moment. But think June, July, and August cumulus season. Cumulus clouds are a predominant cloud type. You see them pretty much every day, these puffy, cottony cumulus clouds. But in the winter, it's more layered clouds. All right. So what happens in the winter season when I get northwest winds? Northwest winds in December, January, and February across Hampton Roads are going to bring me dry and colder conditions. Typically, we see multiple cold fronts pass through our area here. A minimum of 2 cold fronts. Sometimes you get as many as 3 cold fronts per week during the winter season. And we see rapid changes in the wind direction. Typically, we see southwest winds out ahead of cold fronts and then west to northwest winds behind these cold fronts. One other thing with these cold fronts, we get northwest winds behind the cold fronts. You get a steep pressure gradient. So, what I mean by that is there's a large pressure difference over a horizontal distance over a relatively short distance. So behind cold fronts, we get a steep pressure gradient, which results in these gusty northwest to northwest winds and cold air, we call cold air surges. And what that does is northwest winds offshore, you get further away from the shoreline, you tend to build the seas up to elevated heights. So you get really choppy seas offshores when you get these cold fronts to move offshore, the northwest winds. Also, one of the biggest visible clues for me when I know we have northwest winds in the wintertime and a continental polar air mass moving in, we get this deep blue hue to the sky. It's like a cobalt blue appearance. This indicates a stable continental polar air mass in association with surface high pressure building in from the northwest. All right, so I told you I want to explain why we call the winter months, winter season in Hampton Roads, what we call it strata season, because look at this. I got a picture of alto stratus. This is a mid-level cloud here, kind of the ground glass effect. The sun is faintly shining through this cloud layer. In the mid-level is the atmosphere. But see the layer appearance to this? So you notice in the winter season how things are more layered like in the clouds. And then look at here in the summertime. Much more puffy, build up much more to greater heights in the summer season compared to this in the winter season. You see a lot of this in the winter season. Also, down here, I got this at sunset here in Virginia Beach. Notice the layers here, the orange hue to this layered cloud. And really, if we look over here in the upper right, it really explains things in the winter season because what we have is we have these blue H's, these high pressure systems, and these red L's, these low pressure systems or storms that transit in and out of our area here in Hampton Roads in the winter season. And they bring as these high pressures move away from an area, they tend to have rising air on the backside and out ahead of these low pressure systems. There's gradual rising air motion resulting in these layered clouds in between these pressure systems, between this high to the east and let's say this low pressures to the west. It's all associated with larger scale lifting mechanisms, but the slope is much more gradual in the winter season. That's why you get a lot more stratus as compared to summer. Additionally, the sun is much lower in the sky, and it's also much weaker solar radiation incoming to the Earth. Here is what I'm talking about with northwest winds. This is in the winter season. Look at this picture from Colonial Williamsburg. Look at the deep blue hue of these skies. Absolutely no clouds, deep color blue. Continental polar air mass in place. Look at this over here in February. I got this in a February, the past couple of winter seasons. Look how deeply blue that sky is. So this is a dead giveaway. Sometimes you know what? You want to see what type of clouds in the sky, and that'll give you a clue to your forecasted weather. But there's other times where you just want to look at the sky and there's no clouds in it. And right when you see no clouds in it, you want to think, oh, this is high pressure because with high pressure, that yellow arrow is pointed down, you have sinking air in the atmosphere, the vertical, and with sinking air, that results in absence or clear sky, absence of clouds or a clear sky. All right, northerly winds in the months of December, January, and February for Hampton Roads. These are generally associated with mostly cloudy skies Occasionally, we get what's known as bay stream or snow showers into Hampton Roads with northerly winds. Generally, they're non-accumulating snow showers. You don't really get a lot of snow accumulations with this type of setup. You also will see in the sky stratocumulus clouds, which are those flattened cumulus. They set up generally downstream of the Chesapeake Bay, indicating cold air advection. What I mean by cold air advection is you have falling temps moving into Hampton Roads. Stratocumulus clouds do set up parallel to that northerly wind direction too. In order to get bay streamers, you need a strong pressure gradient between high pressure to the west and low pressure offshore. If you get that combination, you get really strong northerly winds, a very strong or tight pressure gradient. So the winds are quite gusty. These northerly winds then blow over or move over the relatively warmer waters of the Chesapeake Bay. They pick up moisture. These cold, dry winds, as they blow over the Chesapeake Bay, they pick up moisture. And when we look at fetch, how much distance there is for those winds to blow over, we maximize that distance or fetch with northerly winds. And those northerly winds blow straight south into Hampton Road cities. The duration is also important. With a strong northerly wind blowing down the Chesapeake Bay in the wintertime, generally the clouds, those stratocumulus clouds we see setting up in rows or lines, they only last as long as the wind blows, that duration. Okay. Here's what a northerly wind sky will look like in the winter season. Look at over here on the left. See these flattened stratocumulus clouds, very flattened, almost looks like pancake batter, doesn't it? Over here in the middle, we see more stratocumulus. By the way, we're driving east at this point, and so you see this. You kind of see these layers of stratocumulus closer to the beach, but kind of setting up there, the bay streamer type clouds. And then over here on the right, I wanted to show you an actual radar image. The red arrow represents a straight northerly wind from Chesapeake Bay down into Hampton Roads here. And you notice the blue returns, reflectivity returns here. That indicates snow showers on this particular winter day. So very strong northerly winds. Look at the length of this arrow represents how much fetch or distance these cold, dry winds move over the relatively warmer waters of Chesapeake Bay. Again, usually results in limited snow accumulations. I have seen a case where we did get a bay streamer snow shower into Newport News and actually brought about an inch of snow to that area. But for the most part, it's just snow showers. You kind of look out your window and say, oh, it's snowing. But it really doesn't last too long. It kind of waxes and wanes in intensity. All right, northerly winds are also associated with significant snowstorms across Hampton Roads in the winter season. What we have is continental polar, that cold, dry air mass in the lower levels of the atmosphere with these northerly winds. And then you get overrunning maritime tropical air mass over the top of the continental polar air mass at the surface. Strong northerly winds are due to a very strong synoptic scale pressure gradient or pressure difference between deep low pressure just offshore and strong high pressure situated to the northwest across the Great Lakes and Midwest. So you got to have that combination, low pressure offshore, high pressure over to the northwest, and what you get is a persistent northerly wind. Some of the biggest snowstorms I personally have observed in Hampton Roads generally have strong northerly winds, just bringing very cold, below normal temperatures into the area during the winter months. I'd say about 2 to 3 days, you have strong northerly winds, just persistent, and they keep that supply of cold air going into Hampton Roads. And then if you get a wave of low pressure to develop off the southeast coast, or even in the Gulf of America, you get some moisture streaming up from the southwest over the top of that cold air at the surface. You're going to get some snow out of it. Northerly winds allow for continuous supply of cold air at the surface with moisture from the southwest overrunning that cold air. So it's a case of maritime tropical warm and moist air moving up and over cold and dry air at the surface. Here's what some of the major snow skies look like in the area. Notice how dull gray and thick this stratus cloud is, right? It starts off in the mid-levels as a nimbostratus cloud, which produces steady rain or snow in the winter here. And then it lowers further and really the visibility drops, especially if it's snow. But this is a typical dull gray snow sky in the winter season across Hampton Roads. Over here on the right, I'm showing an image of the early January 2018 East Coast bomb cyclone. Here was the center of low pressure. You almost like see a clear hole in the center of this thing, looking like a hurricane, for goodness sake. But you clearly see how tightly wrapped this cloud structure is around the center of low pressure here. And then you also see this little stripe of white here over the land areas from Georgia, the Carolinas, up through Hampton Roads, other portions of Virginia. That's the actual snow on the ground in the wake of the departing storm. So just a really neat satellite picture. I always like this one. You see a lot of details within these clouds within this very, very massive, very strong mid-latitude cyclone. All right, what about northeast winds in the winter season? What do those do for us? They're associated with a dull gray, thick stratus cloud deck during the winter season. They generally, when you get northeast winds in the winter months, December, January, February, you get those winter days with lack of sunlight reaching the surface. So you get this dull, dull gray, not dully gray, that'd be a new one. A dull gray, dreary appearance to the sky. It feels dark all day long. Like you'll go to work in the morning on these days with northeast winds and the thick stratus overhead in the sky. No sunlight really reaches the surface through these clouds. And so you go to work in the morning, it's dark. You come home in the afternoon, it's dark. And you think, did he even get light out today? They generally only produce, these stratus clouds generally only produce light precip. You'll see mainly drizzle. Sometimes you'll see that floating mist in the air that will fall from the thick stratus clouds in the winter season. Northeast winds can also be associated with stratocumulus clouds. You get continental polar air, which initially moves off of Nova Scotia, off the New England coast. You get high pressure with a clockwise flow, and that continental polar air basically modifies from cold dry to cold and moist as it moves into Hampton Roads from the northeast. Here is a look at what you would see. Thick, dull, gray stratus on a winter's day. Just doesn't get very bright at all. It's just a really dreary day across Hampton Roads with northeast winds in the winter season. Over here on the right, I'm showing you another example of some of these cold air stratocumulus, which come in off the Western Atlantic waters as well. So you notice you might have a few breaks in these. You might get some sunshine in between some of these cloud elements, but it's generally mostly cloudy with this kind of situation. All right, northeast winds. Not only do they produce thick stratus and these stratocumulus clouds coming in off the ocean in winter, they also can be associated with strong cyclones or storm systems off the coast. Northeast winds can also be associated with low barometric pressure. These storms or cyclones right along the coastline or just off the immediate coastline. Typically with northeast winds, in the wintertime, you're going to get a cold rain across Hampton Roads. The rain snow line will most likely be setting up. I show it here in the bottom right with this radar image. Rain snow line sets up around Williamsburg area. Points northwest of Williamsburg, all snow. Points southeast of Williamsburg, rain. Cold rain. I've seen this happen so many times in the winter across Hampton Roads. What's going on here? You get a northeast wind, right? Northeast wind or even an easterly wind. In any case, east or northeast winds in the winter months for Hampton Roads, those winds blow over the waters, the water temperatures are above freezing. So as the air blows over this water, it's going to result in modification. And in many cases, you get an elevated warm layer, which means that as you go up above the ground, you have an above freezing layer of air, which causes snow to melt into rain before it reaches the surface. So I've seen this happen a lot of times. Now, I know in the Midwest, a northeast wind, you're golden. You're going to get a nice snowstorm in the Midwest. But that does not work that way with this huge influence of the water here in the Western Atlantic into Hampton Roads cities. It just doesn't. This would be a typical example of an image you'd see in the winter of a cold rain. Very dark. See these lights are on? You see headlights of cars on the Interstate 64. And I mean, just this thick, dull, gray stratus cloud producing this rain. Now, southeast winds in the winter seasons are associated in the winter season, these months of December, January, February. These are associated with much warmer air, milder temps, increasing low level moisture. You get some pretty decent heavier rain when you get a southeast wind in the Hampton Roads in the winter season. It's the most common precip type rain with this wind direction. Southerly winds in the winter season in December, January, and February, they're associated with warm air advection or warmer temperatures moving in and increasing low level moisture. In many cases, with southerly winds, especially if you have a retreating cooler air mass leaving the area, right? You have a colder ground. You're going to get warm, moist air with southerly winds moving over a cooler ground, and that's going to result in fog. And you get these fog scenarios with a southerly wind over a colder ground with reduced visibility to less than 1/4 of a mile. And additionally, what really promotes fog formation is the longer winter nights with the temperature and dew point spread kind of getting close together there, resulting in saturation of the lower atmosphere and the formation of this stratus cloud we call fog. Now, drizzle or mist is common in this case. Temperatures are warmer than normal when we get southerly winds. And I have seen this before. The first sign of warm air advection or warmer air moving in during the winter months is the appearance of these mid-level altocumulus clouds as the middle atmosphere warms and moistens first before the lower levels. Here's some examples of winter season southerly winds, what kind of sky condition or weather you'd have. Notice over here on the left, these are the altocumulus clouds I talked about. This is a very common cloud for indicating warmer air moving in. You have clear spots where the air is sinking, these blue areas in between the cloud elements. So this indicates warmer air moving into the area from the south. And then over here in the middle, you see this is town center. You can barely even see the building here, right? Dense fog in both cases here in the middle and the right when we get southerly winds that blow over a cooler ground. So fog is generally going to be, fog will move in generally in the wintertime when you get southerly winds. All right, now southwest winds in the winter season are associated with very mild temperatures during the winter season across Hampton Roads. Some of the mildest winter months have seen a higher than normal frequency of southwest winds. And a prime example of this is December 2015. It was a very warm month. Christmas Eve, the high was near 80. Christmas Day, the high was near 80. Go back and look at your winter temperature anomalies across the eastern U.S. for December 2015. It's insane. That was a case where we had a lot of southwesterly winds, and that's very rare for winter months. You also have record-setting warmth on the backside of an anomalously strong southeast ridge. The appearance of cumulus clouds during the winter months is a true indicator of an abnormally milder air mass. And I'll show you an example of that here in a moment, of the cumulus clouds. And additionally, the warm air mass is unstable ahead of a strong cold front in the winter months. You will get thunderstorms develop, and I have seen some strong to even severe thunderstorms develop across Hampton Roads when you have, that kind of warm air mass ahead of a cold front, very unusually warm air mass. Here's an example of southwest winds. Look at this. See the cumulus clouds here? I took this picture in December. I can't remember what year this was. I'd have to look at my photos again. But this was December, and it was a very mild pattern at that point in time. I mean, this is stratus season, right? You should have layered clouds, not puffy clouds. That tells you right there that it's unusually warmer than normal temps. Oh, this was February 23. I've got it right here. So I took this picture in February 23 from Virginia Beach. Over here on the right, take a look at the winter of 22-23 in general, December to February. These are the temperature rankings from Brian Brettschneider. Look at this. Look how warm it was. Some of the top 5 warmest for some locations in New England. Top 10 warmest winters for a lot of the Mid-Atlantic and Ohio Valley. Just wasn't much of a winter that winter. And this is the kind of sky condition you'd see in the winter months, cumulus clouds, puffy clouds, indicating that unusual warmth. All right, so now I'm going to break down everything we talked about and kind of wrap this video up. All right. In summertime, southwest winds are going to bring the hottest temps and daily scattered showers and thunderstorms. This is associated with a maritime tropical air mass, warm, moist, and sticky. Daily high temps are generally in the upper 80s to the middle 90s. Most days are upper 80s to low 90s, but in July you can get as hot as the middle 90s. I've seen Julys where it gets up to 100. That's generally under a heat dome with less wind. You get dew points of 70 degrees Fahrenheit or greater with southwest winds in the summer. All right, now let's talk about northeast winds. In the summer, they bring cooler air from the North Atlantic into the area. They're associated with fair weather, generally fair weather, outside of tropical influences. That's an important disclaimer to throw at you. So if you have northeast winds just blowing around high pressure over New England into the area in the summer months, it's generally associated with fair weather. You will get lower dew points into the 60s, and you'll get a maritime polar air mass to move in. You look at the sky, you'll see flattened cumulus clouds. In the absence of synoptic scale pressure gradients, you're going to get a sea breeze, or this mesoscale, smaller scale circulation sets up with light east to southeast winds during the daytime. Air is blowing in from the water toward the heated land. Air is rising over the land, and that's why that light wind is blowing in from the water toward land. You'll get isolated to scattered afternoon showers and storms in the sea breeze setup. Towering cumulus, you'll see them building across the sky in the afternoon. Sometimes they blossom into cumulonimbus clouds, which are associated with thunderstorms. Now let's change our. So really in summer, the two predominant winds we see are southwest winds and northeast winds in Hampton Roads. If you don't have any kind of pressure gradients from high to low pressure, you're generally going to get these smaller scale, mesoscale circulation setting up with the sea breeze. In the wintertime, we have southwest winds. We'll talk about southeast winds as well as southerly winds. For the wintertime, southwest winds bring the mildest temperatures with record high temps possible, especially if that southwest wind is strong. And also, especially if we have a very strong upper level ridge off the southeast coast in place. Maritime tropical air mass is going to move into the area from the Gulf Coast with southwest winds in winter. Southeast winds, if the wind goes to the southeast, it brings increasing moisture and potential heavy rainfall associated with maritime tropical air mass. Mild temps will occur. They're not going to be as warm as southwest winds, though. They'll be milder and above average, but they won't be potential record-breaking high temps with southwest winds. So there's a difference there. Southeast winds will also bring you increasing dew points. And then south winds are going to bring increasing moisture in the winter season across Hampton Roads. You get fog and some low stratus clouds, reduced visibility in the fog, and potential rainfall if it's associated with the warm sector of an approaching cyclone. Southerly winds can bring pretty moderate to heavy rain, pretty significant rain into the area from the south. If you have low pressure doing more of an inland track across the Appalachians, let's say, and we're in the warm sector of the cyclone. In winter, also, west to northwest winds bring dry weather into the area with lower dew points and fair weather. Gusty winds and cold air surges are associated with northwest winds, along with significant offshore sea heights. You get a deep blue hue to the sky. That's your indicator of northwesterly winds and the drier air moving in. That's associated with the continental polar air mass. Northeast winds in the winter season bring increased low-level moisture in off the Atlantic Ocean into the area. You get low stratocumulus, those flattened cumulus, as well as stratus clouds, dull gray stratus. You will get drizzle or light precip that's associated with the maritime polar air mass. But in another case, though, with northeast winds, it can be associated with these offshore storm systems or cyclones. We call them nor'easters, which can result in steadier, heavy rain, and it's associated more with the maritime polar air mass. And then finally, in winter, north winds are going to bring in colder temperatures. Cold air stratocumulus, those flattened cumulus clouds I showed earlier. Bay stream or precipitation downstream of the Chesapeake Bay can occur. Usually only snow showers with little to no snow accumulation when you get the bay streamers and the northerly winds, cold, dry air blowing over the fetch of the relatively warmer waters of the Chesapeake Bay. North winds can also be associated, however, with deep coastal cyclones and heavy snowfall accumulation, dependent on the cyclone or the storm system's proximity to the coast. I usually shoot for a sweet spot of 150 to 200 miles offshore. You don't want the storm closer than 150 miles because then you're going to get more of an onshore wind component, easterly and northeasterly, which is going to result in a cold rain for Hampton Roads. But if you get the storm system from 150 to 200 miles offshore, you're generally going to keep, and you have strong, cold, high pressure to the northwest, you're going to generally have northerly winds in place with moisture coming in from the southwest. And even if it's taking more of the coastal track from the northeast, um, you can get yourself a pretty good snowstorm. Now, the stronger the wind speed, the more drastic the change in the wintertime. The weather is going to be from warm to cold or vice versa. Large temperature swings and potential severe weather occurs when you have very strong wind speeds. Now, during the transition seasons of spring and fall, which I did not address in this video, and I purposely did that, I did not address the transition seasons of spring and fall because there's just a wider variety of wind directions and weather which occur. And cloud types are just more diverse in the transition seasons of spring and fall across Hampton Roads. All right, that was a lot of information I threw today in the video here, but I really hope you enjoyed it. I've been in this area for over 13 years, and I closely follow and observe the weather. Between the wind directions, how it feels outside over, summer and versus winter seasons, what the sky looks like with some of these wind direction changes. And I've witnessed a pretty similar weather pattern over and over during the summer seasons and during the winter seasons with various wind directions. And you can get good at this too, even if you're watching from outside the Hampton Roads, Virginia area. You just have to really observe the weather closely and make these notes of what you see, what kind of weather, what's the sky look like, take some pictures of those clouds like this, and then associate it with various wind directions and kind of connect the dots that way. But if you're in the Hampton Roads area, I certainly hope you love this presentation because, I just try to share some of the knowledge I've learned over the years here, so you too can kind of understand how the weather works in the area. All right, that's all I got for now. My throat's getting dry. I know I've been talking a while. I do have another video on the horizon here, and I'm going to talk about Alaskan winters and how they connect with the lower 48, the contiguous United States, how the Alaskan winters and the contiguous U.S. winters kind of connect with each other based on pressure patterns and weather patterns. So I'm building that one right now, and I'm looking forward to presenting that next. All right, that's all I got for now, everybody. I hope you enjoy this. Until next time, take care and God bless everyone.